Section 9.2 deals with ellipses. An ellipse is the set of all points x, y in a plane, the sum of whose distances from two fixed points called foci, one would be a focus, is constant. So in this scenario, we can have two different versions of the formula. Both x and y are squared, and then the major change happens on where a squared is in the denominator. And a squared, or a, is going to be the length of the major axis. If it's under x, it's going to be horizontal major axis, so it'll be long and wide. And if it's under the y value, it's going to be tall and skinnier. So both of these examples down here that I have that break down the parts of an ellipse are both an x squared over a squared setup. And I'm going to point out just a couple of things. So the line through the foci intersects the ellipse at 2 points called vertices. So before we'd have like a vertex, now we can have two. The chord joining these points is the major axis. And that is here for both of them. It's the longer one. And its midpoint is the center of the ellipse, HK. The chord perpendicular to the major axis at the center is the minor axis. That's the shorter one. To recognize that an equation of a conic is an ellipse, notice that there are two quadratic terms with different coefficients now. That's one way to help you tell apart an ellipse from a circle. All right, so to graph and work with an ellipse, first thing we need to do is we need r to be equal to 1 in an equation. So if you look back at our standard form, both equations are equal to 1. So what we do is we divide everything by the radius, that r value. And then we reduce. So I don't want to see decimals. I just want to see a new fraction so we can get our a and b values. So now we can graph. Our center, because there's nothing happening on x squared and y squared, is going to be at the origin. Our major axis is going to be under y. That's the bigger value, so that's our a. So our major axis is y. That means the minor axis has to be x. So it's going to be 12 long. So we're going to go up 6 and down 6 from the center. So that means if I add 6, we'll be at 0, 6. If I take away 6, we'll be at 0, negative 6. We can graph those. The minor axis is going to be b squared is 9, so b is 3. So we'll have a length of 6. So that means we're going to count 3 in each direction. I'm going to share out some different graphics of how you can create an ellipse. And one of them is by attaching a string at the center, I believe, and then you have it like also connected to the two foci. So what you're going to do to figure that out is you're going to do the big denominator minus the small denominator. And that's under the square root. So my big denominator is 36. My small is 9. So when I subtract, I get radical 27, which is not nice to graph or count, but it's approximately 5.19. So each focus is going to be 5 and a little bit more and then we can write them as 0, comma, radical 27, 0, comma, negative radical 27. And that is how you graph an ellipse. Right. If you are given an equation and it's not in standard form, we are going to have to complete the square, yay, and write it. So I'm going to reorganize my x's and my y's together. And I know it is a little tight. Then we need to factor out so that our coefficients are 1. And I'm going to complete the square as I go through. So half of 10 is 5, squared is 25. Half of 8 is 4, squared is 16. And then we need to remember that when I add these two numbers, it's 4 times 25, which is 100, and 9 times 16, which is 144. And it's a little smushed, so I am going to write it underneath. Then we are going to combine some like terms, and we can continue completing our completing the square process. So this will be x plus 5 squared. The 4 stays out in front. And then this is y plus 4 squared with a 9 out in front. And this is going to be equal to, oh, this should be negative 208. Sorry about that. So negative 208 plus 100 plus 144 is going to give us 36. Now we need to put it into standard form where our r is 1, if you're thinking of the equation of a circle formula. So I'm going to reduce x plus 5 squared is all over 9 now, plus y plus 4 squared all over 4 equal to 1. Our center will be at negative 5, negative 4. Our major axis is going to be the x-axis this time because 9 is bigger than 4. So the square root of 9 is going to give me 3. And that's going to go left and right that we're going to count. I can do that now. So I'm going to go 1, 2, 3, put a dot. 1, 2, 3, put a dot. My major axis is 4. So I'm going to go 2 up and down. So this one is much smaller than the first one. And it's a little more circular because our axes are close in length. So once we did our counting, that puts our vertices at negative 2, negative 4, and negative 8, negative 4. And our foci is going to come from big denominator minus small denominator, which is radical 5, or approximately 2.23. I'm avoiding typing in the calculator just to save a little bit of time. So it's a little bit over 2. And there is our example. Okay, next we're going to do one where we don't have a picture or a graph or an equation. We're just going to go ahead and start writing from just the given information. So it's not as bad as I think you're imagining, but it is helpful sometimes to sketch. So we've got a center at the origin, a vertex at 6, 0, and a focus at 2. That's not 2. This is 2. Sorry about that. At 2, 0. So I've got vertex, focus, center. And then negative 6. So it's going to go something like this with some unknown height we're going to figure out. So when you want to figure out the minor axis, what we are going to do is the longer side squared, or the major axis, minus the foci squared length. So that is a length of 2 squared and 6 squared. So 36 minus 4 is going to give us radical 32. So 32 is going to be one of our denominators. And if the origin, or not the origin, the center is at the origin, there we go. My longer axis has a length of 6 from the center, so square is 36, and then squared radical 32 equals to 1. I would like you to try graphing out example 4 on your own. You will get a radical, so just approximate, and then do number 5 as well, and I will go over 6 and 7 and post 4 and 5 in the video for you to double check your work. Okay, here is the graph of number 4 with all the information. The major and minor axes are very close. This does look very circular, but it's not actually a circle. And then here is our information for number 5, which does look like more like a classic oval or ellipse. Okay, let's look at another example. We've got a center, a foci, and both foci, and our major axis. So we're going to want to sketch. So I've got a center at 3, 2. Both foci. So 1, 2, and 5, 2, 3, 4, 5. You can label them if you need to help you keep things organized. And then we've got a x distance, or our major axis, of 6. So I'm going to go 6 from each side of the center. So 1, 2, 3, 4, 5, 6. 1, 2, 3. So we are going to have an ellipse that does something like that at some height. Who knows? And then what we really care about is the distances. So I have my x distance, and I need my center to foci distance, which is 2. So to get the y distance, or the minor axis, we are going to do 6 squared minus 2 squared and get 32 again. So now our equation, because we have a different center, even though this feels a lot like the other example, is going to look like this. And done. We can do the same thing in a vertical direction. So I would like you to try 7 and 8, and I will put them in the video, and then I'm going to go over 9. Okay, for example 7, we have to figure out where the center is. So what I did was I graphed both foci, and then notice that the distance between them was 4. Center's got to be halfway between that. Gives me a value of 2. And then the major axis is total length is 8, so the vertex would have to be 4 away, above or below. So that gives me my 4 squared. So this is my minor axis, which is under x because this one is going up and down. Larger value will go under y because it's going up and down. On number 8, we have the center. We graph a vertex and a focus, and we have the lengths that we need, and this one should be right here. So center to focus is 1, center to vertex is 2, square them, radical 3. This one is taller versus wider, so the larger numbers go under y, smaller number goes under x. Okay. Example 9, we have a semi-elliptical arch over a tunnel for a road through a mountain that has a major axis of 80 feet and a height at the center of 30 feet. So let's sketch what that looks like. So we've got a tunnel with a major axis of 80 feet. So the whole thing is 80. So if my center is the origin, that means I'm going to have 40 and negative 40 for my coordinates. Height at the center is 30, so that means I'm going to go up 30. And we want to identify the coordinates of known points and then find an equation of the tunnel and then also determine the height of the arch 5 feet from the edge. So we're going to go back 5 feet, and I want to know what this coordinate is. So back 5 is 35, so 35 comma 1. So we already know our center is going to be at the origin. Our y distance is going to be 30. Our x distance is going to be 40. So y is the minor, x is the major. So now we're going to square them. Because we have a center at the origin, I have x squared and y squared at the top. 40 squared is going to be 1,600. 30 squared is 900. So there's our equation. Then, to do part C, we're going to plug in 35 for x, because I want to know what the other half of this is, or y. So we've got 35 squared over 1,600 plus y squared over 900 equals 1. Definitely want to utilize the fraction components on your calculator. So when we do that, we are going to want to enter in 1 minus and do your alpha y equals, because who wants to waste time dealing with fraction skills? And we get 15 over 64, so a much friendlier number. So y squared over 900 is now equal to that, all nice and reduced. If you didn't reduce, you're still fine. Multiply. Y squared is going to be equal to 3375 over 16. And we are going to want to talk about the height, and we'll round. I think tenths is fine. So when you take the square root of your answer, we are going to get y as approximately 14.5 feet.